Okay, we are going to go over surface area and volume of pyramids and cones, specifically because they have some special properties. All right, let me put my answer key real quick, just to make sure that I put the right words in the right blanks. Sometimes I forget. Alrighty, here we go. So the first one we have is a pyramid, so one of these shapes. Okay, and it's a polyhedron, so it's a shape that like has a normal shape base. There's triangles on the sides, where one face is called the base. So the base is the one that's sitting on the table. So on here it's green. Okay. So this one has a square base, right? The shape that it's sitting on is a square. Okay, and then all the other faces, so the other sides, are made up of triangles. And they meet at what's called the vertex. So the point of the pyramid on either of these, okay, it's called the vertex. No, let me put my shapes back together. Sorry if it's really loud, it's hard to tell sometimes. Okay, so one face is called the base, right? The one that's sitting on the table is the base, and it can be any shape, any regular shape, right? This one, it has a triangular base, so this would be a triangular pyramid. This one's a square pyramid. You can have a rectangular pyramid. I don't have one of those, but you could have one. Okay, and then the other faces are called the lateral faces. So these triangles that make up the sides are called the lateral faces. Okay. They are triangles that meet at the common vertex of the pyramid. Okay, and you name a pyramid for the shape of its base. This one is a square, so it's a square pyramid. This one has a triangular base, so it's a triangular pyramid. And then the altitude of the pyramid is the perpendicular segment from the vertex to the plane. So basically, if from this point I drop a line all the way through to the bottom, right, and it's going straight, that's called the altitude. So how tall my pyramid is, right, how much up and down it is called the altitude, and it's the height of the pyramid. So sometimes we refer to it as both. They mean the same thing. When we're getting into surface area, we're going to have multiple heights that we're talking about. So sometimes it's nice to have a different name. All right, so a regular pyramid is a pyramid whose base is a regular polygon. So square, triangle, rectangle, the normal shapes we know. We'll just say regular shape. Okay, and whose lateral faces, so those triangles on the side, are congruent, which means equal, isosceles triangles. Okay, so all four of these triangles on the side are the exact same triangle, right? We're just copying and pasting over and over. Okay, these ones, each triangle, all three on the side, same thing. Okay. So the slant height, which we call with a cursive L, is the length of the altitude of a lateral face of the pyramid. So you have the height, if that comes from the vertex all the way through the pyramid to the bottom, to the base. But the lateral, the slant height, sorry, I have the hiccups. I'm trying to not hiccup on camera, is this length right here that's on the outside of the pyramid, okay? So, we'll talk about this two different ways. We'll talk about one with the formula, one without for the surface area. So, to get the surface area, if I was going to paint this whole pyramid, the lateral area is just the triangles together. Okay, so I find the area of all those triangles together, and then to get the total surface area, you add the base. Okay, that's all this is saying. You find the area of the triangles plus the area of the base. So I'd find, it's really stuck together. I'd find these triangles plus this square. That would make it. Okay? Okie dokie. So to fill in our blanks, we can also use this formula. Okay, and it's 1/2 the product of the perimeter of the base and the slant height of the pyramid. So 1/2 of the perimeter of the base times the slant height of that pyramid. Okay, so then to find the total surface area, it's the sum of the lateral area and then plus the area of the base. So this is the area of the base, this is the lateral area. Okay. So some of y'all will prefer this. Some of you would just rather think through it logically of like, all right, what shapes do I have? Can I find the area of those? Add them all together. Both ways, totally fine. Okay, we are going to skip number 4. We're just going to jump to number 5. Okay, so something we might have to do is use the Pythagorean theorem to find the slant height. Okay, so to find this guy, because I need to know this for the surface area. Okay, so we're going to skip to step 2. So I have this whole triangle, a squared plus b squared equals c squared. The whole way across this base is 30 meters. So halfway across is just 15. So to find that hypotenuse, to find that slant height, we have a squared plus b squared equals c squared. Okay. So 36.4 plus 15 squared equals our missing side. Thirty-six point four squared is 1,324.96 plus 15 squared is 225. Add those together. Oh, what did I do? This plus 225. So c is going to be the square root of that. And so something that's nice is we can just leave it as the square root of this. Okay, I could find the square root. That has a lot of decimals. I don't really want to deal with that. So I can just leave it like that for now. Okay. So that's the slant height. I'm going to walk you through how to do it without using the formula. Okay. So the lateral area is just the area of all 4 triangles, right? So that's going to be 1/2 of the base times the height. The base of the triangle is right here, and that's 30. And the height is the slant height we just found. Square root of 1,549.96. So I could just do that. So 1/2 of the base of 30 times the square root of 1,549.96. Okay, so I could leave it like that. So that's one of the triangles. We got 4 triangles, so I'm going to do that times 4. So the lateral area would be 2362.17. Round to the nearest whole number is that. Okay. Using the formula, we're going to find the perimeter of the base. So there's 4 sides that are all the same with a length of 30 is 120. So the lateral area would be 1/2 of the perimeter times the slant height, which is 1/2 of 120. The slant height is the square root of 149.96. Watch this magic. So 1/2 of 120 times the square root 14549.96. Oh. Okay. Maybe if I was better at typing in the calculator. There we go. Okay, and look, you got the same thing, right? So the area of these 4 triangles is 2,362 square meters. Okay, you get the same thing. So some of you will prefer to think about it logically. Just, can I find the area of one triangle, then multiply it by 4? Personally, I think that the formula is a little bit faster. Okay, this 4 in the perimeter takes care of the fact that there's 4 triangles. Okay. So that is the surface area of a pyramid.